Hey, this is Adam Swan with the SOC Prime team, and in this weekly talk, we're going to talk about data sources. So, but first, we're going to go over the challenge from the last week, and congratulations to Mike Riemann, who figured it out and got me the answer first. So let's go ahead and get going here. So, challenge review. Just got to switch over. Okay, cool. All right, so this is the challenge, and it was basically that this challenge text here was encoded with base 64, which I tell you, and then, or actually encoded first with the Visioneer cipher, and then encoded with the base 64. So we have the base 64 string in front of us, and we can just take that and we can paste it into something like CyberChef. So here, you just use from base 64 and you get the plain text. So you can see that I accidentally left the spacing in here, which makes this a lot easier to solve. And I left some hints. So the hint was Prince Hamlet in 18. Well, if you Google Prince Hamlet, it's a play by Shakespeare. So it should give you an idea of what might be going on here. And it shouldn't be too difficult to figure out that this is I guess a sonnet to be or not to be. That is the question. So now, once you identify what the plain text probably is, it's pretty easy to figure out what the key is for a Visioneer cipher. And there's a lot of utilities online. But basically, the way that it works is just the Visioneer table. And if you know what the plain text is and you know what the ciphertext is, then you just do like the opposite. You like encrypt it the opposite way and you get the key. So that's how you do it, or that's how these utilities are doing it. But since we have the plain text, we can just use the plain text attack utility like this, and you can see that if we type in to be or not to be, and the ciphertext is here, we get the key, which was this is a super secret key, which is 18 characters, and that's what the second hint was. And I left that there just in case anyone couldn't figure out what the first hint was going to, and the second hint would be the key length to help people along. All right. So again, congratulations to Mike Riemann, who was able to solve the challenge. And then we do have a new challenge for this talk called Challenge 1. Great name, very enticing, I think. And so the way that this one works is I have encoded 3 files with base 64, an XOR key of FA, and then base 64 again. And the challenge this time is to figure out what the extensions are for these 3 files. So not just the file MIME type, but actually what is the extension in Windows that will get someone to, if they double clicked on it, it would actually perform some sort of action. But again, they are actual payload emulations. They don't do anything malicious per se, but antivirus might care about them. So I definitely recommend doing this one in a lab just to be sure that no one gets in trouble. If AV flags on a production system, and your own SOC is chasing you down. Why did you download this file? What is this file? So sometimes that happens to people. It's not a good thing. So yeah, again, just recommend doing this in a lab environment only. Okay, so now that we've reviewed the challenges, now we can get into the actual core of this talk today, which is data sources. So let's go ahead and stop sharing. Okay. Data sources. All right, so we're going to talk about our favorite, or my favorite data source, which is actually, believe it or not, antivirus logs. And the reason that antivirus logs are my favorite is that they just provide like the most context. And normally AV alerts are the easiest to sort of triage. A lot of times you'll get a hash, or you should get a hash, and just be able to quickly look it up in something like VirusTotal and kind of get an idea if, has anyone else seen this file? What do other AV companies see about this file? And then also for certain things like like PUAs and like PSExec or Nearsoft's like password recovery tools, it can just really give you a lot of insights into what's going on. And actually, with the increase of memory resonant or like scriptlet based attacks, antivirus is slowly starting to catch on and becoming more effective at identifying these things. So a lot of people are looking for that low false positive ratio. And actually, I think the best data source for that today is AV logs. Some other things about AV logs. Nate, did you make it onto the call? I don't think so. No. Okay. So I'll just, Nate has some things that he wanted to share, which was, it's really interesting to look at file types that have been potentially encrypted. So a lot of times when something has had like its header smashed, file header smashed, especially for like zip files, or it's encrypted in such a way that antivirus can't scan it. It'll scan and say, hey, I wasn't able to scan this file. Well, you should pay attention to those, especially look at like the file names and the locations. If you see a lot of stuff in ctemp, see like perf log, cwindows temp. A lot of times those are common locations for adversaries to do staging for like exfil, or just in the root of the drive, like c:/nothing.dat or something like that. Really common areas for adversaries to stage files for exfiltration or stage their tools. So definitely take a look at those and get an idea of what's going on that host if it's happening. Looking at my notes.
Yeah, Adam, can you hear me okay?
Yeah.
Yeah,
I can hear you.
On antivirus logs, I would say they're not obviously most of the time overlooked, right? Just, you always have the false positive problem and whatnot, but there's usually, those you can weed out, right? And there's usually high fidelity like antivirus alerts, and especially coming in on like an incident response engagement or some sort of, there's a compromise, you don't exactly know time frame, day, or whatever. Kind of like starting there, just to double check, like if anything in antivirus happened. Even if it's something like people really overlook, okay, it was, I don't know, a malware Trojan downloader, some Zeus or other like banking Trojan variant that exists nowadays. It's been modified a million ways, quote unquote commodity malware, right? People tend to really overlook stuff like that. Like, oh, I'm looking for, an advanced threat, right? And then for years, people would be overlooking those only to find out 3-4 years later or whatever that certain botnet had been being used by an advanced threat actor to, make their way into networks. Like if I was a malicious actor, malicious entity, whatever you want to call it, like the first thing I would do is just go on quote unquote dark web, right? Whatever underground that you have access to, and just see if I can't buy a bot for $5, at the company you work for, or wherever it is, some Fortune 500, right? So it, as as quote unquote lame as it sounds, it's definitely something that people tend to overlook in various ways, specifically the commodity stuff.
Yeah, and I guess the other point that I wanted to bring up too, kind of along with that, is a lot of your newer analysts, when they view a log that has ADB log, a lot of them have the tendency just to say, well, AV quarantined this file, therefore threat, has been remediated. There's no more threat. Well, a lot of times adversary might have one file flag out of 10 or one process flag out of 10 that they have in your environment. So it's definitely a good idea to train your analysts on antivirus logs, just to say, hey, just because it was quarantined or just because it was deleted, or just because it came back as a PUA or as a commodity malware, doesn't mean that it's not something worth doing a full review on. So
yeah, I like that. I don't know how much you talked about PUA. I dropped there for a second. Apologize, but the PUA, PUA, potentially unwanted application, right? Just some, not known malicious, definitely not known good, kind of somewhere gray area, whether it's installing ads or whatever. But for me, isn't like as a threat hunter or doing incident response or whatever it is, right? Trying to catch bad actors, malicious actors, is if I'm on a network and I see, thousands of potentially unwanted applications or like gray area applications installed on computers, that very quickly is going to give me a general idea of the hygiene of that network. And then I can start to kind of build the different things that I'm going to look for, or the possible evasions or the possible avenues, right? Because, let's say 10,000 person network and, there's only 5 admins, but there's 500 computers with applications installed. That tells me that any user has the right to install applications, so basically you just have to assume at that point somebody's clicking a thing, like it's going to execute, it's going to happen, it's pretty much going to do whatever it wants. Not that that is the end of the world. We all know, not getting into philosophical debate, like go and block everything and can't run this, or your whole network is going to catch on fire, but that helps you as a practitioner, build your next steps, right? Like the more information you can glean from the least amount of stuff, the better, because we all know getting logs is difficult. But anyways, there's a lot just from very little things that you can get.
yeah, cool. So I think we should move on.
One last thing on that. If you're into threat intelligence or, just getting started and that sort of stuff, it can be really frustrating when you get an antivirus alert that says like Artemis ! 74621 or generic 926891, whatever random number and, completely unexplainable name means, is to pivot off of those names actually. So some time ago, I used to use those like really quote unquote generic obscure names, and then Google them, or search them in Virus or search them in other things, and kind of find other samples of malware that had lower hits, against other antivirus companies, if that makes sense. So to some extent, there is a specificity to that generic Artemis, exclamation point, whatever. There is some specific rule. And then if 10 of the 11 antivirus results on VirusTotal are showing like 50 of 52, and then the 11th is like 2 of 52, like you can start to kind of gain information on possibly like what other stuff could be going on with that specific antivirus rule, and that there could potentially be something moving to something else, or finding some sort of relationship. Been able to find some pretty obscure samples using those, wildly vague names. I don't know, Adam, if you've ever had that luck, but
yeah, those Artemis event, like the generic naming stuff, is always pretty frustrating to work with. I always just went in and started pulling the file apart at that point, not so much pivoting off of the names. So if you have a background in malware analysis, normally like with those sorts of events, you can identify rather quickly, okay, is this file actually malicious, or is this just flagging on some packer that was used, and it's not necessarily malicious. So that's normally how I went about it. So normally I would try to identify, like in an environment, just basically, is this file benign or not, especially when they use those generic names. So I would pull it apart, and then also at the same time be looking for, you know, if it's in, especially if it's in like C program data or C program files or an app data, like it might be an application that's actually legitimate. And at that point, you know, actually telling your AV engineers, we need to whitelist these things, is actually something that's that I've had to do a lot with those generic, more often than not with those generic names. I've had to do that sort of thing.
yeah.
Okay. So we want to talk about the most forgotten, and I picked Windows security, but everything but 4688 or process creation events. It seems like if you look at, like, for instance, the sysmon repository on GitHub, there's like, for every other Sigma event rule that's out there, there's probably like 3 process creation events. So process creation is definitely not forgotten about. It's one of everyone's favorites to go to, but the other stuff in Windows security, I think, isn't used as fruitfully as it could have. So some of the ones that I like are actually logon success 4624. You can look for usernames that don't follow the naming convention to identify accounts that have been added. You can look for service accounts with interactive logons. So service count really shouldn't be seeing like logon type 10 for RDP. For instance, is probably the most common thing to see service accounts being used for. And a lot of times that actually ends up being maybe a new employee is on, and someone says, hey, use this service account so we get your account created so you can actually start helping us. Like half the time, that's probably what it's going to be if you find it. But it's still something definitely worth investigating and figuring out. So yeah, there's a lot with logon success, like a lot of logon type 3s to non-file share servers. So if you have like a dashboard that you can set up and you can identify file shares, and you can say, all right, I want to see all logon type 3s, but not these file shares. And you just view a top, like those top 10 accounts. If you view that every day, view a report or something like that, you're going to get used to seeing the ones that are normal, and then maybe one day one sneaks up that you haven't seen before, and now you have something worth investigating. So that's a way to go about reviewing logon success. And then explicit credentials too is really good. It's kind of related. Explicit credentials, again, you can track like remote desktop usage with MSTSC will cause these, net use, run as, psexec, WMIC. So a lot of the lateral movement that uses legitimate credentials is going to cause an explicit credential alert. So it's, or not alert, event. So it's really can be useful. And then account creation 4720. This is especially true. We're seeing more with when RDP is exposed. So if you have RDP exposed to the internet, or perhaps someone learns that RDP is exposed, but in this subnet or something like that, and they get onto that machine, and now they want to set up like a SOC proxy and bring it in. So you can actually see like when users are added to that local remote desktop users group, and to create the account and add it to that group is like huge right now for maintaining access in an environment, especially if they originally got into the environment with RDP. They'll get into the environment, create a new account, hide the account, and add it to that remote desktop users for persistence. And then, yeah, root user rights assigned is another really good one. So 4704. Those are all the special like AD privileges, SE debug privilege, SE backup privilege. I think SE the delegation privilege is another one for delegating in Active Directory. So those are like, if you like, everyone should have rules to monitor for those zesty, most interesting privileges that people can get. I think some of them can be kind of noisy. Actually, SE debug privilege can, in a lot of environments, can be noisier than you might think. So you just have to kind of get an idea of what's normal in environment and maybe make some recommendations to reduce that noise actually, and then it can become more useful. So yeah, scheduled task creation 4698 goes into Windows security logs, and it's still a really common form of persistence. Malware, APT malware has been, just commodity malware has been using it since scheduled tasks existed. It's kind of a built-in persistence mechanism, so it's definitely worth reviewing scheduled task creation events. And then finally, you can actually monitor if you set SACLs. It's not the easiest thing to do, but there are PowerShell utilities out there now to do it. But you could set security access control lists on files and actually do some file auditing. So if you have a file share, or you have an NTFS file share, or you have a computer that has a lot of sensitive files on it, you can set these SACLs, and then the computers that access them, if they're Microsoft boxes, will actually log when those files were accessed. So that 4656 is the object access. It also can do registry and handles and other things as well. But I think a lot of people are really concerned about how do I access, or how do I monitor access to specific files in my environment, and the 4656 object access can take care of that for you with a little bit of configuration. So definitely something to look into if you haven't already. Nate, did you have any favorite things about Windows security logs that maybe people should be aware of?
Yeah, I mean, the Windows event logs it's been explored obviously for quite some time, right? But didn't really become really useful. I don't want to use the word super, but didn't become really useful in thousands of different ways until Vista, right? So let's say 12 years ish, maybe a little more, 14, I don't know, right? So not long, but really been discussed in depth like the last 5 or 6 years. So I think this is something that's constantly going to be, it essentially, as I always say, Windows logs is pretty much to your own creativity, like is the only limit for the most part, right? So just thinking of some things, certain scenarios, right? Like you have the network is pretty restricted, there's no internet at all, it's quote unquote closed gap. Maybe there's USB restrictions, or people just aren't doing that at all. But like people are printing things, and there's Windows event logs for the file name that was printed, the bytes of that file, and those sort of things, right? So you can do it pretty easy, like display some bytes by a user, how many things that they printed in a day, and then compare potentially a week, 3 weeks, or 60 days. So it's a really obscure way of exfiltration, kind of muddies a lot of people's thinking of, encrypting something, putting it on a CD or uploading it to the internet or going through a command and control or an email, right? But there's a lot of environments like that. Another one is, wireless, like monitoring wireless network usage. There's Windows logs for the wireless network that was connected to the SSID name, the encryption type, as well as a few other things, right? And I think that's important because if you have static devices at a company, right, at a building, which it probably doesn't apply so much nowadays, but there's still uses for it, even at home, right? But if they're connecting to something outside of the SSID that your company, uses for that building, or even at home if they're supplied like a MiFi or whatever else it is, or if you have 4 or 5 of your top users, your C levels that are constantly connecting to open Wi-Fi, you could potentially do some sort of training, figure out who and what. But without going for, forever on this, I think probably one of my biggest favorites, and this will go into my next point, but kind of like who's watching the watchers. So you have all these, and with that, I'll say specifically on Windows side, group policy. So you have, group policy is the thing that makes sure all your devices are configured the way that they should be, both for the user and for security and for just system administrators, right? It's probably one of the most powerful management platforms. And so, who's watching those modifications? Who's watching group policies being pushed? If I have a group policy that says, turn on Windows Windows Defender, and then somebody goes and modifies to disable Windows Defender in that group policy, who will know? Like if a tree falls in the forest and nobody's around to hear it, did it still fall? Like it's kind of one of those scenarios that a lot of people are missing with group policy in various modifications. It was always a continuous thing for me to, I'm deploying these things. How do I know that they're still on? Not just like that the log is being collected, because I might not know that a log is happening until it happens. It might not only happen one time, but just even from that modification of that policy layer, which brings me into my next thing, is like one of my most favorite data sources, and another like forgotten one is management network devices, or just management devices and network, meaning like routers, switches, your span, your tap, your firewall, and so forth, right? So you could spend, all this money on really advanced span and tap technology to pass packets over to your network security monitoring tools or other various tools, even like a Defender, Microsoft AZP Defender tool that monitors one of the domain controllers using some like packets, right? Would you know, like you just have to ask your question yourself, like would you know if somebody edited that span or tap policy if they added an exclusion of an IP address or added an exclusion of a port? People say, oh, I would notice in volume, but if it's like an actor, you're seeing this more and more with all these insider threats, somebody being paid a few $100,000 just to modify SIM cards for phones, right? Like, why wouldn't an actor pay somebody $30,000 or X amount of money to just like, hey, add this IP exclusion to your span or your tap or your IDS, or add this hash to your antivirus or whatever it is? I think you get the drift. So like who's really watching these modifications? And with that, my last thing on this point is, with the recent 0 days and some of these vendors, switches and router devices, and I think MITRE, somebody from MITRE, like kind of coined this term or saying, but like routers and switches are endpoints too. They're no different, right? They're just not seen as a hands-on keyboard user type device, but they have processors, they have memory, they have storage. There's at this day and age, especially with some of these next-gen firewalls, like they are legitimate web servers. They're going to be attacked and abused just as such, and just because they're on a management network doesn't make it any more or less like likely to be attacked at the end of the day, like if that's what your company or your entity like faces, you know. It's a lot more difficult to conceptualize because monitoring management devices, there's not a lot of like phased portions where you can catch the attacker, especially if it's an insider, right? There's no initial access, there's no persistence, there's no lateral movement because a legitimate user, who's acting as an insider already has those, they work there, they were given a password. Their persistence is they hold, a job. Their lateral movement is that they have access to those systems that they use from their device and log into. But over time, it's not as difficult, as it seems. People shouldn't constantly be making administrative changes or whatever it may be. Adam, do you have anything to say on that? I know you have some experience on that as well.
Right. Yeah. The network devices. Yeah. I think if you're not following that they're just regular endpoints, and I think like the vendors really have to accept that too. Like they are serving up these web servers and not necessarily making it easy to, they're not making the audit logs for those web servers available. You have to have a proxy in front of most of them to get the logs you need. And even that could be hard, like if the device doesn't support break and encrypt, but the web portal's encrypted, it can be really difficult to like identify these attacks against these web servers on quote unquote network devices. But yeah, they're just all, most of them are running Windows. Not Windows, sorry, Linux, some form of it, customized. And probably like Nginx or any other Apache web server, maybe stripped down. So yeah, they're all equally as vulnerable, or maybe even more so, just because they're not used as much. Like Windows boxes are everywhere, and everyone is constantly researching them. And now recently, with all these 10 out of 10 CVEs that have been coming out, it's just like, what is this? This is unauthenticated file access. There was one recently that was just astounding. It was like, they had authentication. You could authenticate to their device, but you didn't actually need to perform any administrative action. So if you knew the URL and the schema to post and make a change, you could do it. So you could add a user or run any function on the. I think it was like a firewall. I don't remember exactly what it was, but yeah, you could do any administrative function without being authenticated at all, which just seems like a bug out of like the early 90s. So yeah, it's crazy. Like a lot of people are concerned about the Internet of Things as well, and I think it's definitely in the same. It's kind of in the same bucket for me as monitoring your network devices. Like there's so many of them, there's not enough researchers looking into it, and so therefore it's not known that these things have these problems, and therefore they're ripe for targeting. And it's also like, just generally, if you have a really advanced adversary, they might only go after your management network. Like they might only have to do that because maybe all they want to do is be able to hit a button to turn you off one day. If something, if they don't like something you say, or you're about to come up with some new technology that will make their technology in their country, inferior, and they'll lose big market share for their state-owned businesses or something like that. Like, yeah, they might just go after your management network just to be able to turn you off one day. So yeah, I think it's really important to look at those events.
Yeah, and I mean, just some more like practical examples of, like applicability. Like you said, just any way, like I take that as a form of denial of service, right? Not in the true sense that people think of denial of service of overloading a web server with fake traffic, whether it be a bunch of web requests or, one small request that can be amplified into many larger requests, 1-to-10 ratio or some sort, right? But that is a form of denial of service. Like you're disrupt, that's a motive of an attacker to disrupt an organization. So doing payment processing, if you are, a web server, if you're an MSP or an internet service provider, a cell phone provider, like the list just goes on and on, manufacturing devices and those sort of things. But I mean, even with the group policy modifications and the management stuff, that's been one of, I don't know if it's Maze or not, but one of the ransomware groups, like just make it to there and then just push out stuff via group policy. Like there's no better way to make sure that you touch every single device on the network other than to use group policy, and I think applicability for additional things, right? Like an actor going back to like a cell phone provider or an ISP, like they don't really exfilling data or whatever else, doing lateral movement. Like they just want to make it to, the router or the switch that passes internet traffic for a certain company or a certain just human being, just one person, right? And they're just going to basically do a packet capture on that one user's IP address, and that's pretty much it, right? There's not a whole lot of lateral movement and executing processes. They just want credentials to SSH into a box, and that's about it. Probably not much different than the normal network admin that's SSHing into that same device, unless you're able to log those commands that are being ran. At the end of the day, it's just a SSH session. So yeah, trying to give some form of applicability of conceptualizing some of those things.
Yeah, cool. I think we've gone beyond Windows security, but that's okay. Like, yeah, there's definitely other forgotten about things, and network devices, definitely, and management network stuff is definitely one of them. But I think we can move on to the final thing, which is common mistake. And for this, I picked DNS logs. A lot of people are collecting DNS logs, but really like placement of where you're getting your logs. If you do it wrong, it can be really, really difficult to triage any sort of activity that happens. So I'll give you a real life example somewhere where they were collecting DNS logs at their perimeter. So basically, there was at least 3 hops that DNS was making outside of all the local host lookup stuff that goes on. But it was going from, or sorry, 2 hops. It was going from their endpoint to their domain controllers, which is pretty normal in a Windows environment. And then from there, it was going to this perimeter device. Well, they were collecting only at the perimeter device. So whenever something malicious, a malicious domain or a malicious looking pattern that they were concerned about flagged, and they had this like rich data, they didn't have anywhere to run with it, because whenever they looked at what the source IP was for who was actually making the lookup, what do you get? You get the domain controller. And then if you're not collecting the log of the domain controller, any logs of the domain controller to actually go and figure out, okay, what host made this request, you're kind of in this la land. Like maybe you can use endpoint tools. We had some success doing that occasionally, like look up all the internet history for all the hosts and pull the domain that flagged and see if anyone went to it that way. And some hosts maybe had some DNS events from Sysmon, and we could look through there. But it's like the most frustrating thing in the world when you have an indicator that you actually care about quite a bit, and you have no way to correlate it back to an endpoint, an actual endpoint to initiate remediation steps and perform additional hunt. So this is a quick one for me, but that is huge. Like, make sure that wherever you're pulling DNS logs from, that you're collecting as much as possible. Like today, in today's age, it can be kind of more difficult, especially with people who are allowing their employees to use their own hosts, or everyone's working from home, and maybe DNS is going through their ISP's router and not through your environment. So like really, DNS is really tough. So really, you have to try to get it as much of the data as possible. So if you want to be effective at using DNS logs, but that's it for me. Nate, did you have anything to add to that?
Yeah, again, I think it's one of those things that, as if anybody knows me, right, I've been on about this for a long time, but I think like collection and things that working at home, right, like I think taking it back to management devices, DNS is a necessity, right? There's the running joke of first thing is something is broke, like the internet is broke, website is down. It's always DNS. And from like a malicious standpoint, at some stage, there's probably going to be a domain. Can use a direct IP, but that's a lot easier from an IOC for that thing to be burned kind of forever, that IP address or whatever it is. But DNS is always allowed in some form, right? And then you go into DNS tunneling, and I don't want to get to the whole DNS tunneling over HTTPS, because what I'm directly referring to is DNS tunneling on management networks, even in some really quote unquote poor hygiene or what people would view as like that place is always going to get hacked. Like networks like that, their management networks still had, no outbound traffic allowed, like legitimately, like it worked, right? But DNS was allowed. So DNS tunneling was always a thing, right? So it was pretty much like one of the only ways to transfer stuff out, or some sort of C2 communication, right? DNS tunneling is one of those things. Written a blog about that's pretty easy to detect. But with that, beyond the whole beyond the whole management thing and the work from home, Sysmon Event ID 22 has made DNS collection, really useful. Has kind of expanded the gap, or even really made it possible in an easy way to collect DNS logs from endpoints. Even if you're only doing it while the device is connected to your VPN, if you're able to do that, because at some point there's going to be a beacon, right? And then you probably don't want to know what a user is doing while they're not connected to a VPN. That's another subject, but with that, for Windows endpoints, like Sysmon Event ID 22, then you have Packet Beat, or like Zeek, the new Zeek endpoint agent for some of the Linux stuff. In correlation that you talked about, Adam, of only the external IP, is there's a kind of lesser talked about field in DNS called like transfer ID, but it's essentially just like a unique session ID assigned to that DNS lookup that traverses the wire, right? But then also the endpoint or your internal DNS server, the thing at the lowest, would have. So you might suffice to just collect it from that internal DNS server, using Windows DNS debug log or the event channel. That's in 2012 and 2016 server edition. So there's a lot, a lot to kind of unpack in DNS, a lot of various avenues, and might be short-handed, right? But I think there's solutions that you can be creative with to solve various things. And last thing I'll just say is DNS as a whole. And again, with people working remote, this doesn't apply as much, but I think even at home it does. If you're not controlling like DNS in some form or fashion, I always like to go back to in 2014 when FireEye wrote a report on Hurricane Panda, just one of the Chinese APTs who had basically poisoned a DNS server, like a lesser used one, poisoned a DNS server so that adobe.com actually pointed to their C2 IP address. So when these bots or the computers that they compromised were connecting their C2, they were making connections to on the wire, the HTTP request, and whatever else it was looked exactly like adobe.com. So, the form of manipulation you can do, like if you are controlling DNS, you control a lot. Not to mention just, DNS is what makes Kerberos and Active Directory work. So a lot of mistakes. It's overlooked a lot. It is difficult to get actionable data from that. I will admit that. I think Adam, you could probably admit that as well. Having monitoring a DNS server, that's exposed to the internet. There's a lot of things in that. But I think I'll cut it off at that for DNS.
Okay. And then, did you want to talk at all about the SigRed? Or I can just pull up Tedium.
Yeah, if you want to pull it up, and I can talk to it. That way, we don't have to pass back and forth. But
right. Yep. Sounds good. So,
yeah, and I can just briefly explain the rule. I did the DNS via DNS. This should be down too on that page.
Yeah, I'll just
it should be the third one. Third one, you're way down. Yeah.
Here's the third one is DNS. I think it just got updated.
Okay.
The proxy one got bumped off the front page, I think. I'll just type SigRed.
I see it. Via DNS.
Oh yeah, here it is. 1, 2, 3. Yeah, they're in a row. Sorry, it was the brackets that threw me off. So which one do you want me to click on?
The via DNS.
Okay, sorry.
No worries. Yeah, so yeah, it's getting cut off. Anyways, so SigRed, just quick second for those who might not be familiar, is just basically with an integer overflow. Adam, you could correct me on that, but basically just a large response for a specific type of DNS request, triggers and execute, like triggers a vulnerability in the DNS software on Windows servers, right? So what was really interesting to me, and why I don't know if I'll update this rule for the bytes greater than, because not a lot of DNS log sources have this byte, has the byte size in the log. I think the Windows debug does, but I don't know if it's hex encoded or something else, right? So writing your rule with like hexes greater than or hexes between, and there's a lot of these passive sensors and even these multi-million-dollar monitoring tools don't have this. But anyways, the point of the fact that was interesting to me of the type of query is coming from some pretty large environments with terabytes of DNS. Like this is not by any stretch of the imagination a common query type, right? You usually see A or quad A being IPv6 DNS lookup, and A just being your standard. Might see some variations of CNAME, and some other things with like domain controllers, right? But SVR or SRV records. But yeah, this is something that's really rare. Actually, had somebody like verify my thinking behind this, and they had gone through a few terabytes of DNS logs and only had 10 or 12 hits in 5 or 6 terabytes, and it was one host. And this rule wouldn't even hit that. So it was a very interesting vulnerability, and I was very pleased to know that it was on a very obscure DNS lookup type. And obscure, even if it's legitimately used in your network, you can even do it by the domain. So if the community starts to find out like there is a domain that is exploiting this vulnerability, like that could then be an IOC that you could look up through other means. But you can whitelist based on or filter based on the server as well as even the domain, which is, I went, just by the rare query type, then by the source IP, and then querying that domain multiple times within a certain period. So again, like I said, I don't know if I'll update this for the bytes variant, because I also believe, with all that in mind, I also believe like you should know if this is happening on your network, just to learn and understand your network, or if there's something odd is happening.
Right. Yeah. In my testing, I didn't see, in the networks that I had access to, I didn't see any SIG queries. So yeah, just looking for a SIG query itself, I think, or RSIG, is very useful for this specific CVE. But if it's really common in an environment, I'm sure there's some environments where they're happening a lot more than others. Then there are some other queries, like based off of command line or proxy logs too. So there's 2 other rules that might help you. But this is probably like the closest to the actual CVE detection that you can get. The other ones are just going to identify, like the command line one is basically like the DNS process acting unusual. So if someone were to spawn something from it, child process from it, that would be considered unusual, because DNS normally doesn't, with the exception of like if it's DNS crashes, it might launch WRFault. I think there was one other one that it might launch that was normal. So that's another good one. And then,
yeah, I think with that we're covering both avenues, right? Like not everybody has endpoint logs. Be great if we all did. It's not a perfect world, right? So you're covering the endpoint side and then the network side as well. As what and even passive. And this is a rule, like, people have obviously written scripts to add the specific field that you would need to certain software to be able to log the bytes field to make this, quote unquote, more bulletproof or more it's higher fidelity, right? But again, in this field, being able to write something that applies to the majority with also least amount of resources, which I think is important to me.
Yeah, we always take that approach with TDM for all the rules that we're writing. We're trying to write rules that cover the gambit of what people have. So I saw something from Florian Roth posted today that had me cracking up about people's, like certain log sources like Firewall. I think he posted on there basically saying that someone was using all their Splunk or Elastic licensing on firewall logs and not collecting the more fruitful, the easier pickings that come from Windows Windows logs or antivirus logs, or something like logs from network logs from Zeek, for instance, are more rich than firewall logs for the most part. So, and I guess it kind of depends on what kind of firewall. Like some of the new like application layer firewalls and stuff can be really rich, but like if you're just pulling, you know, this port was blocked from this IP, made a request to this port and it was blocked. Okay, well, what are we going to identify with that port scanning? Like you're only going to really identify unsuccessful things. It's probably like discovery, you know, not so much lateral movement. There just isn't enough context in a lot of those logs to make a decision. But when it comes to, you know, Windows logs or network logs from Zeek and DNS logs, they're a little bit more rich with data. So we always try to pick those data sources to write rules against that. A, people might have, and B, they provide enough context that you can actually make some sort of decision. So. But with that, and Nate, unless you have anything else, this concludes the second weekly talk. So Nate, do you have any closing comments?
No. Thanks for listening. Thanks for joining. That's all I have.
Yeah, and don't forget the challenge. If you solve it, just my DM on Twitter is fine to message me, or you can just tweet at me with the answer. So yeah, have a nice weekend, guys. Thanks for watching, guys and gals. Thanks for watching.